This is an Ellis screw jack. A lot of times we use these in trench collapse to set some shores. We can also use them in structural collapse. You can see the length of it. What you want to do is when you're measuring your strut, you want to subtract 10 inches off of this. That way you have enough room in there. This has got a 6-inch throw to it, so I can raise this up. Again, it's a real great shore when we're trying to set temporary shores. We got a lot of height change in the building that we're trying to go into, so I only have to build one shore and I can take it in and it can be more versatile for me. When we're doing this, you can unscrew this to change that height or lower the height. We just want to make sure that we get it centered onto our sole plate. When we're putting this together, it's very important that we make sure that this strut is seated all the way in the bottom of this cup right here. To do that, make sure that it's seated all the way down, make your measurement to make sure that you know how long this is so it's completely planted in the bottom of it. It's very critical that we get that complete double funnel all the way through here to make sure that that load transfers and we're not just holding it up on nails. I don't recommend putting nails in the side of these in these holes to hold that in place because it gives us an opportunity to hold that up and make it so we're not transferring that weight all the way through it. Once we've got that through, the rest of the shore is the same thing as the T-shore. It's no different. We just got to make sure that it's nice and level, we have a good wood-to-wood contact, and it'll really go together just like a regular T-shore. We're going to tighten these up. To tighten up one of these Ellis screw jacks, you can just twist it, just like he was doing, and run it up. Once it gets so tight, you can take your hammer and lay in there and tighten it up like that. Okay? Remember, we don't want to raise the building. All we want to do is capture that load. This is a mechanical advantage. Anytime you have that inclined plane, it is a mechanical advantage. A screw is a mechanical advantage, and that's what that is. All right. The other thing we have up here at the top, see how we got this gap right here? We got to fill that. Okay, so we can take 2x4 wedge packs and fill that entire void right there. Take this out, and you can fill right in there to make that so it's a solid contact. Remember, because we have this gap right here, that means there's going to be travel if anything shifts and comes down. That makes sense? And then we're going to have an impact load on that shore, and we can't have an impact load. It is acceptable to turn this T-shore this direction. So you have the header going one direction, the sole plate going the other direction. The reason being, you get a house that may have a room addition or something like that, where you don't have the same direction for your floor joists as you are your trusses. You need to be able to capture everything. You can't take this thing and set it so it's going to drive right down into the floor. All right? Why do you think that it is critically important to have things as level as we possibly can? All right, if we take this shore and we'll hold 1,000 to 4,000 pounds square. How many pounds will it hold when I rack it just a little bit? You have no idea. All right, you have no idea what it's going to hold.